Hi guys, and welcome back to my course. In this video, we will talk about virtual DOM and what happens when render method is called. We all know about the browser DOM. It stands for Document Object Model and it represents our web app in a tree-like structure. Every time something changes in our application, the DOM gets updated to reflect those changes in the browser. This is all well and good, but the problem arises when we have to frequently update the DOM. It affects the performance by making our application slow. Whenever a DOM element is updated, its child nodes also need to be re-rendered. This re-rendering or repainting of the UI elements is what makes the whole process slow. Therefore, the more UI elements you have, the more expensive the DOM updates will be, because the browser will need to re-render more number of nodes. This is where React brings virtual DOM in the picture. As the name suggests, the virtual DOM is a virtual representation of the actual DOM or the browser DOM. And just like the actual DOM, the virtual DOM is a node tree that lists elements and their attributes and content as objects and properties. Virtual DOM is a representation of the user interface. So whenever the state of a component changes, a new virtual DOM is created. The new virtual DOM is compared with the previous one to find the updated nodes. If there are some nodes which need to update, then only those are updated in the browser DOM. But if there are no differences between the old and the new virtual DOM, then the browser DOM is not updated. This makes the performance far better when compared to manipulating the real DOM directly. Can you guess when does this process of creating new virtual DOM starts? Well, if you remember, we have a method called render, which is responsible for rendering the UI. When the component is created, or when the state is updated, or when the props are updated, the render method is called, and it creates a new virtual DOM, which is compared to the previous virtual DOM, and the UI is updated based on the differences. And this process of comparing the virtual DOMs is called diffing. And that's all for today. I hope this gave you a better understanding of how the virtual DOM works and what happens behind the scenes when render method is called. But if you have any doubts or queries, feel free to drop a comment below or reach out to me on Twitter. I'll add my Twitter handle in the description below. See you in the next video. Bye and take care. Hi guys, and welcome back to my course. In this video, we will learn about the life cycle of React components. There are 4 stages in a component's life cycle: initialization, mounting, updation, and unmounting. Initialization is a stage when the component starts its journey by setting up the state and the props. The initialization process is done inside the constructor. Mounting is the stage when the component is created and inserted in the browser DOM. This stage comes after the initialization stage is completed. This is the stage when render function is called for the first time. Then we've got updation. So this is the stage when the component is re-rendered due to the state and or prop changes. Then last or the final stage is unmounting. This is when the component is unmounted or removed from the browser DOM. This happens automatically when the browser tab is closed or the route is changed, which results in mounting of different components, or if conditionally we unmount the component. There are different lifecycle methods that React provides for different stages of a component's lifecycle. React automatically calls the responsible method according to the stage in which the component is. These methods give us better control over our components and we can manipulate them using these methods. Guys, pay very close attention here. These lifecycle methods are only available in class-based components, but we can also add lifecycle hooks in function-based components using a feature provided by React called hooks. We will talk about this hooks feature in the coming videos. Now, let's check out components creation lifecycle methods. When the component is created, first the constructor is called. The constructor can be used to set up state and props for the component. Then, when the render method is called, it also renders all the child components of that component. When the current component along with its child component is rendered, React calls the final callback, which is component.mount. It just tells us that the component is mounted in the DOM. This is the stage when we should make API requests to fetch data and update the component state. There is one more callback method, get derived state from props. This is called right before render method. We will talk about it in the later videos. Let's check out these callback methods in our code. So coming here, this app.js is a class-based component. So let's try adding a constructor here. Now the constructor will get access to the props, and we can call this super method. The super method is responsible to call the constructor of the parent class, which in this case is the React's component class. We can also move our state inside this component, so let's do that. Now if you remember, I mentioned this state is a property of the component class. So to access it, you need to use this keyword, so this dot state. Let's save it. Let's try adding a log here, say inside constructor. Let's save it. Similarly, let's add a log here inside our render method, say render called for app.js. Let's also add the lifecycle method component.mount. So component.mount, and let's print it here as well. Say component.mount. So coming back here, let's open our console. And as you can see, first we got inside constructor printed, then render was printed, and after that component.mount was printed. So just like we discussed, the sequences followed. Now I also mentioned that the child components are also rendered before this component.mount is called. So let's try that. So in this case, we have this blog homepage card component. So this is a function-based component. So let's try printing a log here. Say blog card rendered. And let's remove this unused import. Let's save it and let's check our console. So as you can see, first we get inside constructor, then we get the render called. After that, we get these blogs rendered. So as you can see, this is printed 3 times because we had 3 cards here. And after that, finally, this component.mount is printed. And that's all for today. I hope this gave you a better understanding of component lifecycle. But if you have any doubts or queries, feel free to drop a comment below or reach out to me on Twitter. I'll add my Twitter handle in the description below. See you in the next video. Bye and take care. Hi guys, and welcome back to my course. In the previous video, we saw different stages of a component's lifecycle, which were initialization, mounting, updation, and unmounting. We tried the callback methods of the creation cycle. Now let's check out components updation lifecycle methods. When a component is updated, the first callback method is shouldComponentUpdate. This method returns a Boolean value, which decides whether the component should be updated or not. By default, it returns true, but we can conditionally return true or false to avoid any unnecessary re-renders. If the shouldComponentUpdate method returns true, then render method is called. And as you already know, this is where the browser DOM is updated. When the render method is called, it also renders all the child components of that component. When the current component along with its child components is updated, React calls the final callback, which is component.update. It just tells us that the component is updated in the browser DOM. This is the stage when we can make API requests to fetch data from the backend. There are 2 more callback methods in the update lifecycle: get derived state from props and get snapshot before update. We will talk about them in the coming videos. Now let's check out these callback methods in our code. So coming here inside my app.js. So if you remember, the first method was shouldComponentUpdate. So let's add that here. So as I told you earlier, by default, it returns true. So let's return true by default. And let's print inside shouldComponentUpdate. After that, render is called. So we've already printed it here, render call for app.js. Let's comment this for now. And the final stage is component did update. So let's add another here. So component did update, and let's add a log, say inside component did update. Let's save it and let's check it. So these were the creation ones, so let's close them. Now when I click on this hide list button, it calls the setState method, which updates the state, and the updation cycle is triggered. So as you can see, when I click there, the first statement is inside shouldComponentUpdate. Then the render method is called, and then the component did method update is called. If you also remember, I mentioned after the render method is called, even the child components are rendered, and then this final callback is triggered, component did update. So let's check that also out. So now when I click here, so if you notice, it's not getting printed here. So the reason being, we are removing those elements on this button click. So if I click again, those components should come back. So now as you can see, first it's shouldComponentUpdate, then we've got the render method, then these block cards are rendered, and finally component did update is called. So coming back to the code, so if you remember, I mentioned shouldComponentUpdate decides whether the component should be updated or not. So if you return false here, even when the setState method is called, our component will not get updated. So as you can see, it goes inside shouldComponentUpdate, but it does not go beyond that. It does not trigger the render method. No matter how many times I click here, it just goes till shouldComponentUpdate, but it does not go beyond. So that's why if you put some condition here and based on that you return true or false, you can avoid any unnecessary re-renders. So right now I'm just returning it back to true. So when I click here, as you can see, everything's working perfectly fine. All right, so now let's check out the components deletion lifecycle methods. Here we just have one callback method, component will unmount. It is called when the component is being unmounted. So as you can see here, conditionally we are unmounting these block cards. So whenever the show blocks is false, we are removing these block cards from the DOM. So I'll just quickly convert this to a class-based component. So class, and this needs to inherit React's component class. Now all the class-based components have a render method. Let's put all this other code inside that render method. You cannot directly use props, so this would be this.props. So let's change it to this.props. Let's save it. Let's check it. And as you can see, everything's working fine. So now this is a class-based component, so we can add that callback lifecycle hook here. So component will unmount. Let's try printing it. Say unmounting block cards. Let's open the console. So now when I click here, as you can see, shouldComponentUpdate, render is called, and then this method is called unmounting block cards, because we were removing those cards. And that's all for today. I hope this gave you a better understanding of component lifecycle. But if you have any doubts or queries, feel free to drop a comment below or reach out to me on Twitter. I'll add my Twitter handle in the description below. See you in the next video. Bye and take care. Hi guys, and welcome back to my course. In this video, we will learn how to improve performance by avoiding unnecessary re-renders. If you remember the lifecycle methods, there was one called shouldComponentUpdate, we can use it to avoid unnecessary re-renders. We all know that rendering is a heavy process, especially when the layout is very complex. And every time the setState function is called, it starts the entire cycle of component update. A new virtual DOM is created, compared with the old version of virtual DOM, and then it updates the actual DOM. This can hurt the performance of a React app drastically if done wrong. So the rule is simple. Avoid unnecessary re-renders as much as possible. And how do we do that? We can use the shouldComponentUpdate lifecycle method. It gives us access to next props and next state. We can compare if the values are changed or not. If the values are changed, then we can re-render, or else we can avoid it. Another thing to remember is that React is very fast. So normally you wouldn't have to worry about adding shouldComponentUpdate to improve performance. But if you notice that your app's performance is not good, then you can use auditing tools to benchmark the performance and use shouldComponentUpdate at the right places to get the best performance. So coming back to our current product details component, even when the same item is clicked, the component gets re-rendered. So opening our console. So as you can see here, when I click on this item, it prints rendering app.js. When I click again and again and again, as you can see, it keeps printing rendering app.js. Now these are unnecessary renders. Nothing is being updated in the UI, but the update cycle is triggered. So let's try using shouldComponentUpdate to fix this problem. So coming here. So whenever this color option is clicked, this position, it updates current preview image pos, which is a state variable. So let's try adding shouldComponentUpdate lifecycle method here. So shouldComponentUpdate. And as I mentioned, it gives you access to next props and next state. So next props and next state. So if you try printing it here, say next props, let's print next state here because we are handling it on state changes. Similarly, let's also print current state. So that would be this dot state. For now, let's just return true. So coming back to our browser. So now when I click on this red one, so as you can see, we've got the next state. So in this case, current preview image position 1, so which was the red one. And for current state, the current preview image position is 0. So this is the previous state before updation. So all we have to do is just put a condition if these two values are same or different. So if these values are different, that means our component should get updated. But if these values are same, that means our component should not get updated. So coming down here, let's put our condition. So if next state dot current preview image position is equal to current state dot current preview image position. So that means if both the values are same, which means the user is clicking on the same preview image. In that case, return false. Let's just comment these console statements here. So coming back. So now when I click on this red one, as you can see, rendering app.js is printed. Similarly, when I click on this blue one, it gets printed again. But now if I click on the blue one again, as you can see, it's not getting printed. So if you print here, say inside shouldComponentUpdate, let's try again. So when I click here, as you can see, it's getting updated. But if I click on the same one again, it goes to shouldComponentUpdate, but it returns false. And that's how it helps us improve the performance by avoiding these unnecessary re-renders. Now this was a very simple use case, but this is how shouldComponentUpdate works, and this is how you can use it to avoid these unnecessary re-rendering of your component. And that's all for today. I hope this gave you a better understanding of performance optimization using shouldComponentUpdate. But if you have any doubts or queries, feel free to drop a comment below or reach out to me on Twitter. I'll add my Twitter handle in the description below. See you in the next video. Bye and take care.